Here is the question that I ended the last part of this video lecture with, and hopefully you had no trouble with it, but many people are fooled by this one. Notice there is an interaction between the car and the truck. These two forces between the car and truck are the two forces that are parts of that interaction. So this is an interaction pair, where the agent and target have been swapped. And what we've just seen about interaction pairs is that these forces always point exactly in opposite directions and always have exactly the same magnitude. So it might be counterintuitive to you, but the force that the car exerts on the truck is the same size as the force that the truck exerts on the car. There's some language that's useful when talking about these interaction pairs of forces, and it's that forces have targets and agents. So remember, every interaction occurs between a pair of physical objects. So for example, the interaction between my hand and the wall, so the wall exerts a force on my hand and my hand exerts a force on the wall. Well, each force has to be exerted by some physical object, and likewise every force is exerted on some physical object. So looking at the force by my hand on the wall, we say that my hand is the agent of this force. It's the thing exerting the force. And likewise, the wall is what we would call the target of this force. But now if you look at the partner of this force, the other force that's part of this interaction, which is the force by the wall on my hand, now the wall is the agent of this force, and my hand is the target. So the agent and target get swapped when you go from one force to its partner, which is the other force in the same interaction. The language that we use here is important and can be very helpful, and I encourage you to use language quite carefully when you're talking about forces. You should make it clear whenever you're talking about a force what its agent is and what its target is. So we might say that Bender exerts a force on the steel beam. We're saying that Bender is the agent of this force, and the steel beam is the target of the force that we're talking about. Likewise, we could say that Stuart is pushing up on a banana, and so Stuart is the agent and the banana is the target. We could say this same thing by saying that there is a force on the banana due to Stuart. And there are various other phrases along these lines, but the phrases should make it clear what object, what physical thing is the agent of the force, and what other physical thing is the target of the force. Your first task anytime you're trying to think about a situation using forces is to identify all the forces that exist. And this isn't a trivial skill, it takes practice. Let's think about our two classes of interactions. We have contact interactions and long-range interactions. Well, contact interactions result in what we will call contact forces, and these happen anytime two objects touch. And so identifying them isn't so hard. You just look for where things are touching other things. So for example, when I lean on the wall, I'm touching it, and so there's a pair of forces by my hand on the wall and by the wall on my hand. When you slam into the mattresses, there's an interaction, and so there's a pair of forces by you on the mattresses and by the mattresses on you. Similarly, if you pull a car using a rope, then the rope exerts a force on the car. The car also exerts a force back on the rope, which I haven't shown. When a boat is floating on the water, it's touching the water, and so there must be a force that the water is exerting on the boat, and likewise a force that the boat is exerting on the water. An airplane stays in the air because there is a force that the air is exerting on the plane, and of course that also means the plane must be exerting a force on the air. And you can speed up in a car because you can make the road push forward with a frictional force that acts on the car, and at the same time the car must be exerting a backwards frictional force on the road. Long-range interactions can be a little more subtle. We say they result in field forces. We could call them long-range forces, but I'm going to use the term field forces to set you up for the next course, Phys 1204, where we talk a lot about fields. These are forces that can act at a distance, and so because there's no contact, it's not always obvious when these forces are occurring. We need to look for their effects to see that they exist. So for example, when you drop masses, they accelerate downwards. That's because the Earth is gravitationally pulling on them. There's a force by the Earth on the mass, which is a gravitational force. Similarly, I was able to push magnets around using another magnet because there is a magnetic force that requires no contact. But just like the contact forces, these come in pairs. So because the magnet in my hand A exerts a force on the stack of magnets B, the stack of magnets B must exert a force back on the magnet in my hand A, and I can feel that force. Less obviously, when you drop the masses, or even if you don't drop them, there is this force by the Earth on the masses, and so the masses must also be pulling up on the Earth gravitationally. That may not be obvious, but we see its effect all the time. The Moon orbits the Earth because the Earth is pulling on the Moon gravitationally, and so the Moon pulls gravitationally back on the Earth, and we see that most obviously through the tides.